Okay, so let's get started on this problem. There's a couple different ways to do it. We could, first of all, it says determine all the forces in the truss. So there's 1, 2, 3 bars that we have to find. We could, with 3 bars, so in our notation, B would be 3. How many reactions are there? 3. There's 2 at A and 1 at C, so there's 6 unknowns. And how many equations can we write? We can write 2 equations for each joint. 1, 2, 3. So we have 6 equations and 6 unknowns. So it's a determinate structure, and since it's triangular, stability is pretty much guaranteed. So I think the best way to work this problem would be to find the reactions first. That's usually a pretty good first step. So I'm going to do that first. So I'm going to come over here and just kind of sketch a free body diagram of the structure. And we're going to have an applied force of 60 kilonewtons. And then I'm going to come along and I'm going to make assumptions for my reactions. I'm going to assume I have a reaction at C. I'll call it CY. That's a roller, so we know it's free to move in the X direction. I have a pin at A. So again, I'll assume that I have a reaction in the Y direction and a reaction in the X direction. I'll go ahead and put some dimensions here. And we know the height is 5. So how can I find these reactions from this free body diagram? Well, probably it'd be best to sum moments, right? You can probably sum moments at A or sum moments at C. I'm just going to make it easy for myself, really no particular reason, but I think it's safe to always sum moments at the pin. You have 2 unknowns passing through the pin, so they will create no moments. So I'm going to sum moments about A. So I'm going to use right-hand rule, and I'm going to sum moments about A to make sure it's in equilibrium. Everybody see that? So we'll start in the front today. Who's that sitting down there? Mr. Heyman, how do I sum moments today here? What kind of moment does CY create? Positive or negative?
Positive.
Positive.
CY times 5.
Okay, that sounds reasonable. Who's next? Mr. Grand, what's the moment about A for the applied load, the 60 kilonewtons? Is it positive or negative?
Negative.
Negative. And what's its moment arm? What's the distance from A to this line of action of the force? Correct. I'm going to run out of room here. Sorry about that. Just barely squeezed it in. That's kind of almost not easy to see. So if I solve for CY, what do I get? Looks like I'm going to get 120. And it came out positive. So that means that CY is up. Any questions about that? All right, so now I'm going to sum forces in the Y direction. Make sure it's in equilibrium. So what do I have? Mr. Sontag, what sum forces in the Y direction for me?
You'll have AY plus CY, which is 120.
Let's not do that yet. So we got, looking at the free body diagram, we got AY, CY, and then what else?
Minus 60.
Minus 60. So we do have AY, so I can plug that right in there. And I should be able to solve for AY. And what is AY? I think you'll find it's minus 60. Is that right? Does that make sense? Well, if you look at this thing, it's kind of like a seesaw, where here's the pivot point. If I pull down 60 here to keep this thing from moving, I better pull down 60 on the other side. Does that make sense? Ms. Mills, you get the next one. Just to finish this off, let's sum forces in the x direction. Make sure it's in equilibrium. What's the forces in the x direction? Just ax. So ax is 0. So we got 3 of the 6 unknowns pretty fast. So now we want to do our method of joints. Okay, so I have 3 possible sites, A, B, and C. And let's just talk hypothetically first. Can I go to A and be successful? Well, how many unknowns at A now? Well, there's the force AB and the force AC. So two unknowns, and I know what's happening at A. I found that. So I can write 2 equations at A and 2 unknown. I can start at A. Can I start at B? Sure, right? There's 2 unknowns. There's AB and BC. The geometry there might be a little tricky. And actually, we could have started there without even having the reactions at A, right? And C. And then finally, how about C? Well, again, 2 unknowns, AC and BC, so that's a good spot, and we know CY. So I'm going to suggest that we focus on A and C just because this AC member is all X. And these other ones just have Y components. If you look over here, both these elements have X and Y components. That would be probably a tricky place to start. You'd probably write 2 equations and 2 unknowns. You might have to solve those equations simultaneously. You won't have to do that at A or C. So just because I'm going to do it alphabetically, I'm going to start at joint A. So this is my common joke I always do at this point. I'm going to draw my free body diagram of A. You guys ready? There it is. It never works. I keep trying. Okay, so I'm going to apply now my forces at A. So I found AX was 0. It's not there. I found AY, which I assumed up, is negative 60. So that means it's actually down. And you might be saying to yourself, Dr. Camp, you said don't change your signs. Well, I'm not. I didn't go back to my original diagram and change anything. I'm drawing a new diagram. So I can put what I know onto that diagram. Now I'm going to assume that I do have a tension force going from A to C, and I have another tension force going from A to B. So what is this angle? What is this rise over run? Well, it looks like in the x direction it goes 5 meters, and then it goes vertically, 10 meters, and it goes vertically 5. So that's kind of a 2 to 1. Everybody see that? So it goes 10 units to 5 units, which is basically 2 to 1. Rise over run. Now looking at this structure that I have here, what would be, should I sum forces in the x direction first? I should ask Mr. Curry, he's next in line. Mr. Curry, should I sum forces in the x direction first?
I said sum Y first, since you already got that 60 there.
That's true, but if I sum them in the x first, what would happen? I get one equation in 1, 2 unknowns. You can't really solve that. But if I sum in the y first, only one of my forces has a y component. Everybody see that? So let's do that. Try to make it easier on yourself. So one equation, one unknown is nice. So I'm going to sum forces in the y direction. So Mr. Bell, what is the sum of the forces in the y direction? What's the y component of AB?
1 over the square root of 5 times the force.
That's right, 1 over the square root of 5. And how do you get square root of 5? which is 2 squared plus 1 squared is 5, and the hypotenuse would be the square root of 5. So that's really the y component. 1 over the square root of 5, and that's FAB, and it's acting up. So for my sign convention, that's positive. And then what's left?
60 the negative 60 kilonewtons.
Negative 60, yeah, negative 60 kilonewtons. So what is the force in AB? You just need to take 60 multiplied by the square root of 5. 132.7. I just guessed. What is it?
134.1.
134.1. Anybody else get that? And that should be positive, right? Positive means what? Tension. Any questions about that? So, Mr. Wynn, what's next? Yeah, let's sum forces in the x direction. So what is the sum of the forces in the x direction?
2 over factor 5.
Right, so 2 over the square root of 5 is the x component of AB. It's going to the right, so that's positive. What about AC? Positive. Anything else? I think that's it, right? So I can plug my value for AB into here. It looks like AC is 120. Is that right? And it's negative. Negative means compression. Let's stop and make sure that this sounds right. So what I'm saying here is AB, which is this value here, under this load, if it's in tension, that means it's trying to get longer. And simultaneously AC, which is this element here, is getting shorter. I think the shorter one's easy to see, because as you pull down here, is C likely to move left or right? It's going to move left, so that means AC will get shorter, so that's in compression. And if that moves in, then probably BC is going to move out a little bit, and it'll go into tension. So that seems reasonable. So what do you suspect BC would be? Compression or tension? I'm hearing both answers.
Going down on B, wouldn't that shorten BC?
You think B is going to move up? No, it's probably going to move down. So I bet you this is going to be in compression. So let's see. How do we find out? We need to go solve for it. How do we do that? We can go to B or C, but I think joint C is going to be the easier of the two to work with. So let's draw a free body diagram at C. You ready? Here it comes. Oh, isn't that beautiful? So what are the forces acting at C? Well, we have CY, which we solved for, of 120. It's acting up, so I'll have 120 acting up. I have a tension force in AC and a tension force, or assuming a tension force, in BC. Sorry?
You didn't do joint B because...
Well, both forces have X and Y components.
But you already had AB. Force
Yeah,
AB.
but I don't have to get all those X and Y components,
Okay.
right?
I just thought it was...
I'd have to get the X and Y components of AB and BC. This one I'm only going to need one guy, X and Y. Just, I think it's a little less work. You can be successful at B. I guess my general philosophy, and you can probably espouse to it also, path of least resistance. I'm like water.
It's negative.
Paths of least, if there's a crack, I'll find it and I'll drip through it. Yeah. No, I always assume tension. Because I assume tension on this end, It has to be equal opposite on the other end. I don't think about it. You're thinking about it, Mr. Patel. Don't think about it. Always assume tension. What's the slope of my line here? 5 to 5, which is 1 to 1. So what's the hypotenuse? Square root of 2. Now, I want you to remember that we've already solved for FAC, right? So what one equation can I write to get BC? Should I sum forces in the x direction? I can. What's the disadvantage?
Error.
I incorporate a previous answer, which could be wrong, which guarantees my answer for BC to be wrong. How can I get it independently? Sum forces in the y direction. So if I assume up is positive, I'm going to sum forces in the y direction. Who did I leave off on? Mr. Gupta, what do you got in the y direction? What's the y component of BC? 1 over the square root of 2.
Times
And that's up.
and then so
What else is acting vertically?
the 120 and
The 120. That's also up.
Dr. Ken, where'd you get that 120 right there?
That's the reaction at CY. We saw for that at the very beginning. So it looks like BC is going to be negative, and whatever 120 times the square root of 2 is. That seems reasonable. 170, anybody get that? Three significant figures is enough. So it also kind of confirmed our intuition that BC was going to be in compression. So because I always assume tension, I can look at my answers and know that AB is tension, AC is compression, BC is compression. And we're going to try to keep that convention throughout the course, especially when we start doing our computer modeling. And this is as good a time as any to remind you or to announce to you that we will do a demo. I'll do a demo of the SAP 2000 software in class on Thursday. So bring your laptops. Let me show you. Oh, I better stop this. Any other questions?